Good afternoon, everyone. Uh, I'm Asmit Ghimire. If you don't know. So today I'm going to talk about the art of refactoring. So yeah, let's just get started with the introduction. So let me just brief about the refactoring. What is refactoring, man? Let's go through it. So refactoring is the process of restructuring code while not changing its original functionality. So code refactoring, what's the scope of code refactoring, man? We don't refactor code in order to like change the functionality or the output of the certain block of codes or whatever feature you want to refactor. You just want to reorganize the restructure the code base in terms of strengthening its maintainability, readability, and such. I've also listed the purposes of refactoring and what it enhances in terms of code readability, maintainability, and overall quality of the code, making it easier to understand and modify while reducing technical debt. So talking about technical debt, in a long run, a refactored code would help a lot in terms of maintainability cost of the code bases. So yeah, we'll talk a lot about the actual impact of the refactoring as we move along the slides. So let me just move into another section. So let's just talk about why refactoring matters first. Uh, the first point is obviously improved code quality and readability. So you always, you guys, all most of the developers here already have faced the problem, I hope. So trying to jump into the older code bases and not understanding what the code is trying to say unless you go into the documentation and stuff. So for that, if the code is well written and readable, it would help the other developers to carry on with the development. So the other point would be maintainability. Same goes with this one. It would help in terms of maintaining the code bases in long run. And the other would be the reduced technical debt. Once the developers have to spend less time in understanding the code and adding features on it, it would help reduce the technical debt. So that would also tag along with the quicker issue diagnosis of the code bases. That would also be helpful if the code is refactored and more readable. And the other would be the enhanced team collaboration. So yeah, this is the major part of the refactoring impact that drops down the technical depth of the code bases. So once you have a good collaboration of the team, the whole project runs smoothly. You will know how to write codes and what to add and what not to do. So this also it would involve PR reviews and stuff who would be enforcing those code practices in the project. And improved extensibility. So with that, it means when you want to extend the features on top of the code bases, it would be easier and it would be the improved system basically if the code is more readable and structured. And also I should have put on design patterns here as well, but basically it also covers that scope as well. So the extensibility of the code bases would be easier if it follows certain design patterns and you know how to extend it, which is properly defined and standardized. And also performance gains in some cases. So this is not the main focus of refactoring, but you would also want to refactor code in terms of strengthening the performance of the code bases. Like some code blocks could be using some loops and unnecessary iterations of code, which could be reduced by chained methods that the frameworks have introduced. Like in Ruby, you can chain certain objects and methods as well, which would be very efficient compared to for loops and while loops we use traditionally. So yeah, these are some of the factors that refactoring would be helpful for us and why it matters. So let's talk about the science. It's time to refactor. So when do we refactor? Obviously, you don't want to refactor the time you initiate a project or something, but yeah, it has to go side by side. It's like a parallel thing. If you want to I'll talk about in the further slides about the complexity of when to refactor and when not to refactor. How do you get along with both code bases and refactoring and feature development in the same time? So one of the reasons could be code duplication. Of course, you don't want to like duplicated codes in your code bases, and long methods and functions. You might want to like granular division of the methods and functions. So if that can be divided into like smaller chunks. Complex conditional statements. So complex conditional statements would be like harder to grasp as well in terms of readability of the code. So you might wanna maybe refactor the code base if the complexity of the conditional statements grows even larger. And tight coupling. So tight coupling would be another problem that you might want to get rid of. And when it comes to refactor, there could be like two modules, and they could be like tightly coupled. And if you like want to make changes to one module, then it would like impact the another module, and you have to like work two ways. So that would be one thing that you might want to refactor the code bases as well. So I've not talked about all the examples I've listed here. I'll be going through a few examples, and I also want to like write a blog on top of this. So in there, I'll go on more detail on explaining about the examples of each science and whatever technique that I'm displaying over here today. So other would be performance issues. Like I said, there could be time when you want to like refactor your code if it's impacted with its performance, and changing requirements as well. So as you know, when the project is designed, it is designed in one sense of business logic, and when the business logic changes upon time, the particular code base that you have written might not be possible to handle the changing conditions and stuff. So you might want to refactor those modules as well to go along with the changing requirements. And the last one is excessive comments. So I don't know if you guys write comments on your code base, but it is a good practice that we developers must have. And there's also excessive comments, which would be a problem. Your code itself should be readability, and your comments should not always be the one to describe your code base. So yeah, that too it goes along parallelly. There should be comments, but there should not be much comments is what this point is trying to say. So yeah, your code should be readable by itself is what code refactors want to help us with. We want to use code refactoring in terms of that factor as well. So let me talk about few refactoring techniques. So some of these are some fundamentals techniques that we all follow. I just listed those as well because these small changes do make a large difference in terms of readability, and when the code base grows larger, you will have problems like trying to find out the variables that are not descriptive. So if you like tag along with these changes as you grow the code base, it'll be very helpful. So let me just go through the list as well. So descriptive names to variables, methods, and classes. So everything should be descriptive in terms of its functionality. Basically, users don't define a variable as A, B, or maybe not just a user and maybe an active user, if that helps. If you are trying, your code is like grabbing an active user, don't just say user. It's an inactive user. That'd be more descriptive. So you don't want comments on there because your code is self-descriptive in this manner. So same with the replace magic numbers with named constants. So you don't want to use 1 or 2 in comparison. Like 1 could refer the start of the day, maybe Sunday, but maybe define a constant which holds the integer 1, and that would be very descriptive in terms of readability as well. Consolidate conditional expressions. So this is basically when you have a bunch of different expressions, conditional expressions in one method. Maybe you could like consolidate them into a single condition if that helps your code readability. The other would be introduce parameter object. So this is about combining multiple parameters in a single object. So yeah, what parameter object is trying to convey is if you are like passing two different attributes of same object, like maybe a user's phone number and email, you might as well just pass it an object having both the parameters in a single. So that would like decrease the parameter, and maybe you have like 5 or 6 parameters, and it would violate the standard of maximum parameters. So you can like combine those parameters into one object, and it also helps in code readability as well because you would know the scope of the function at one glance. So that would help in terms of refactor as well. Remove dead code, of course. You don't want unnecessary code lying in your code base that is not in use at the moment, which are obsolete. separate concerns with design patterns. So this is about the design patterns, and if the code base is not following the standard, the design pattern that it has been introducing, then you might want to like separate the files. Basically, let me say for an example, you might want to like remove the business logic from your controllers to a different service file or whatever design pattern you're following, maybe a manager or something like that, which handles the business logics. So this would be another way of refactoring as well. And the other two methods I have described there is pull-up method, push-down methods, and replace conditionals with polymorphism, which I want to like illustrate in a diagram as well with an example. And there's a picture over here, which is like kind of giving a sense of when you want to refactor and what refactoring would help. So there's a start and endpoint destination. Like you could go through the winding roads through the forest, or you could like go take the highway, which is a little further, and then take the straight path. And maybe you'd like traveling at 40 kilometers per hour in this winding road, and when you like hit the road that's 10 kilometers away from your start point, then you can like hit 100 kilometers per hour speed and then reach your destination quicker. So that's one way of like illustrating what refactoring would do to your code. So basically what this example is coming from is it's a technique called preparatory technique, to be specific. So this is done basically when you want to extend your features. You might want to like align your already having features first and then add another feature on top of it before doing so. It's basically you refactor your code first before adding features on top of it, because once you add code on top of it, refactoring would be even harder because maybe the modules and the business logics have already changed by then. So let me go with the pull-up method. So this is an example. So you have, the problem is your subclasses have methods that perform similar work. So you can see soldier and tank, they both have, it's a little faded, but it's a get health method that both are using. And these are subclasses and this is the parent class. So if the both subclasses are using similar functions, then you might want to pull that method up to the parent classes. And that way you can refactor and you'll have less codes lying around, which is duplicated. This also helps in dry principle as well. Do not repeat yourself. So basically, this is repeating. This is the problem, and you might want to push up to the unit, which is the parent class of that subclasses. So same goes with the push down method. So this is the opposite of pull down method. So you have a get fuel method in your parent class, but the soldier is not using that. Just tank is using it. So you don't want that in the parent class. Push it down to the subclasses which actually uses it. So these both are opposite. So we just implement these both techniques in order to refactor our code as well. The other would be replace conditionals with polymorphism. So yeah, this is the thing that I don't like, and I usually practice this kind of abstraction of methods. So you can see here, the problem is you have a conditional that performs various actions depending on object type or parameters. So there are basically many switch cases here. So this is a PHP code. Let's not go into the syntaxes. I just want to present the idea of the block. So I'll be explaining it. So here's a switch case for each type of bird. One would be European, another would be African, another would be Norwegian blue. They just want to get the speed of that bird, and they're sharing one function that's repeated everywhere: get base speed, get base speed, get base speed. It's just not about the method they're using, it's about the block as a whole. The whole code looks a little messy when you look at it for first glance before you read it. So how do we solve this problem? It solves with polymorphism, and the example would be this one. So what do? You create subclasses with matching the branches of the conditional. Whatever conditions that were there, you create subclasses for them. So we had European, African, and Norwegian blue bird, and then create a shared method that move code from the corresponding branch to the conditional of the conditionals to it. So you basically want to move the repeated methods into the subclasses of the function, then replace the conditional with the relevant method call. So basically, the bird would be the abstract class over here, and the subclasses would be European, African, and Norwegian. That way you could just define the bird subclass over here and get speed, and the abstract method would work for you. So this would be an example of abstraction as well, polymorphism, and refactoring in terms of managing your conditionals with polymorphism. So let me talk about steps to successful refactoring as well. So how do you do it? So there's a process You first identify the target area for refactoring. Of course, you don't want to refactor a whole app at the same time. If that's the scope, your whole app would be in the scope. Understand the existing behavior and write tests. You want to write tests because you don't want to break things, you could like miss out things when you refactor and the output might be different. So you might want to first write tests on top of the existing methods that you want to refactor. And then that way you could like run tests again to verify if the code is broken or not once you have chosen the refactoring technique. Of course, choosing the refactoring technique would be another process. So this could go along with the design pattern you want to follow. If you want to refactor in terms of design pattern, if you want to refactor in terms of optimization, you might want to improve your queries and stuff. So that would be the techniques you would be choosing basically. And the last thing is you just commit the changes. So yeah, keep calm and refactor code. So I also want to highlight few tools and resources that I find very helpful. One is SonarQube. Provides extensive static code analysis, detecting bugs, vulnerabilities, and code smells across the multiple languages. And another one is Code Climate. I think you are used to Code Climate as well. So Code Climate is very helpful. It also offers insights and metrics. So there's an example. So it says it basically breaks down the whole code base. It says the number of files it has. It gives the rating for the maintainability of the code and test coverages as well, and also code smells and stuff like that. So with these stats, you could like figure out what you want to refactor and which module is lacking in terms of code smell and stuff like that. So yeah, lastly, let me talk about the challenges. So yeah, we all know that code refactoring helps, but there are always challenges, right? So what are the challenges? Time and resources, of course. A feature comes down, there's a strict deadline, and you don't have time to refactor. That's always there. But the main motto is, let's just go through all the challenges first. So the another would be risk of introducing bugs. You don't want to introduce another bug, so you just get rid of refactoring. You don't want to do that unless that's necessary. Another is lack of automated tests. So that would be a challenge in terms of refactoring. You don't have automated tests. You need to first write automated tests before diving into refactoring, if you want to be sure that you're not breaking anything. Legacy code and dependencies. Legacy codes, of course, is a problem. You might not understand the previously written code bases or the dependencies that they are using, and you don't want to toss the legacy codes. Team buy-in. So basically, this is like convincing your team members and stakeholders that you want to refactor, and that is helpful for them in the long run and for the business. So basically, they're like, the code is working. Why do you want to refactor? So this is like conversation or team buy-in that you got to do before jumping into refactor. That's a challenge as well. Scope creep. So by scope creep, it means like you kind of end up refactoring small module and it bubbles up into bigger modification in the code base. So that could be another reason or another challenge in terms of refactoring. Balancing refactoring with new features. So of course, this is always there. And resistance to change. Yeah, the main thing is resistance to change. You gotta be daring enough to go ahead and refactor your code bases. Until and unless you're daring, you would always resist for the change, and your code base would always be piled up in terms of code smells and stuff. So yeah, these are the challenges. The main message that I want to deliver is that there's always challenges. So when you like code, you have to have that parallel sense of refactoring going on in terms of designing code in the first place. So don't just design code in terms of functionality and stuff. Just think about how it grows in the further line of the business, what problems that you could face. So with that, whenever you like write codes in the first place, you have a habit of like writing it in a modular sense, modularized code bases. Also, like defining proper design patterns would help you like streamline those techniques and stuff when you write codes. So you have to like go side by side is what I think would be helpful. And yeah, it's an incremental change. You make certain changes as you develop, and the outcome would be very fruitful. See another example, code refactoring is like doing the dishes. It's not fun, but leaving them all piled up will make things worse. So yeah, look, she's not happy. Thank you. Thank you, guys. That's it.